So we're going to start with 2.4. 2.4 is variables and equations. Okay. So earlier in 2.3, we talked about variables and expressions. Okay. We did things like 224 plus 2 times k plus 2. And then we simplified this by doing, this is 24, I do this, I get 2k, 2 times 2 is 4, so I can further combine these two, the ones that do not have k's, right? The one that I have a k is still 2k, then I go 24 plus 4 to be 28. So I'm simplifying an expression, right? This is just this guy here is an expression. It's not exactly, it's not really an equation, right? If it was an equation, you would have something like this on it, okay? Where you would have an equal sign, and on the other side, you'd have a different number or maybe a different even variable expression, okay? But then you could solve for k, okay? Earlier, when we had variables and expressions, we weren't solving for anything, we were just simplifying it. Whereas now with an equation, you can actually solve for the variable, okay? You have a solution, okay? So let's go and see if we can go ahead and go to example 1 and writing verbal sentences as equations. So this is very important because this is the building block of you guys doing well on the word problems, okay? Many of you have struggled with the word problems, okay? So let's see what we can do. Let's see what we can do. Example number 1. In example number 1, we have A. The sum of x and 6 is 9. The sum of x and 6. So how would I represent the sum of x and 6? So you would say, well, x plus 6, right? Because it's the sum. The sum of x and 6 is equal to 9, okay? We're not going to worry about solving this right now, but we're just worrying about putting this into a correct expression, okay? B, the difference of 12 and y is 15. The difference between 12 and y. So how would I find the difference between 12 and y, okay? Difference between 12 and y looks like this, right? 12 minus y. Because let's say the difference between 12 and 8. If I want to know the difference between 12 and 8, I would subtract 8 from 12. The difference between 12 and y is the same thing. I'm going to subtract y from 12. And that was going to be equal to 15, okay? Again, we're not going to worry about solving it right now. We're just worrying about putting it in the correct expression, using the correct equation, coming up with the correct equation. The product of -4 and p is 32. Product is what? Product is when you multiply things together, correct? So the product between -4 and p, that would be -4 times p is 32. Okay. D, the quotient of n and 2. The quotient of n and 2. Okay. So D, the quotient of n and 2. So this is fairly or kind of confusing because the quotient between n and 2 is n divided by 2. Okay, sometimes you want to look at it this way, but this is not correct. The quotient between n and 2. Okay, so this one over here would have been the quotient of 2 and n, right? This is the quotient of n and 2, okay? The quotient of n and 2 is 9. It is 9, so this would be equal to 9, and then you would try to solve it, okay? You would try to solve that. Example number 2. Let's go to example number 2. Example number 2. Tell whether 9 or 7 is a solution of x minus 5 is equal to 2. So whether 9 or 7 is a solution, right? Let's say that if 9 was a solution, then I would put it into x and see if it works. This is all we're doing. We're substituting for x the number, right? So I'm checking to see if 9 is a solution. If 9 was a solution, then 9 minus 5 would equal to 2. Well, 9 minus 5 is 4, and 4 is not equal to 2, so this does not work. Therefore, 9 is not a solution, right? Let's check 7. If 7 works, it would mean that 7 minus 5, wherever x is, I put 7. So I substitute for x, I substitute 7 in. 7 minus 5 is equal to 2. 7 minus 5 is 2. So this is true, which means that this guy is a solution. Okay, so this is how you check whether a number is a solution for an equation. You just substitute it back in, okay? All right, flip the page. Let's go to example number 3. Example number 3. Solve the equation using mental math. Okay, the equation is this. And we're going to solve this using mental math. So some number plus 3 is going to be equal to 11. Well, that means that that number had to be 3 smaller than 11, right? Or it would have to have been 8, right? In other words, because 8 plus 3 is equal to 11, which means that x, your solution, is x equals 8. Okay? And we have b, we have 16 minus m is equal to 9. So from 16, I subtracted something and it became 9. Okay, so what number do I subtract? When I subtract from 16, do I get 9, right? So it would be 7, correct? 16 minus 7 is equal to 9. Okay, that's all we're doing, right? Number C, I have 20 is equal to 5 times t. So here we're looking at what? 5 times a number is equal to 20. So what times 5 is equal to 20? Well, it would be 4, right? So t is going to be equal to 4 because 4 times 5 is equal to 20. Okay. Then we have D where we have y divided by 3 is equal to y divided by 6. So we have d y divided by 6 is equal to -3. So what would y be here? So y would be what? Y would be 18 here, but it's a negative, right? 18 divided, because 18 divided by 6 is 3. Which means that to get -3, y would have to be -18. Okay? All right. So example number 4, from 1998 to 2002. No, 1998 to 2002, biologist Jane Shen Miller grew several lotus plants from ancient seeds she found in China. The oldest seed was about 500 years old. Estimate the year when the seed was formed. Okay. So since we found it at 2000, right, we found it at year 2000. So whatever year that it was, plus the 500 is equal to 2,000. This is what we're looking for, right? So some number plus 500 is going to be equal to 2,000. So this is going to be what? 1,500, right? Because 1,500 plus 500 is 2,000, correct? All right. Okay, so that's it. And we're done. We're done with 2.4. Okay, so let's go ahead and start working on your homework.